The science of road building usually means waiting. Waiting for pavements and subsurfaces to fail, and watching and wondering how long it will take. All the advanced testing in the world won't tell us exactly how a pavement is reacting to the stress and strain of ever-increasing traffic loads as they happen. Layer by layer, a road illustrates the best technology of a time. Its materials are characteristic of a place. Its chemistry is unique to a climate. The materials and methodologies with which it was built are distinctive to an era. A road is, in fact, a sort of time capsule. A time capsule both buried and exposed that lies dormant while subjected to decades of change. Increasing traffic patterns, heavier loads, and changing weather conditions. And like a time capsule, someday, someone in the future will look back and try to understand what happened and why. Roads and highways in the United States and throughout the world are overstressed and showing serious signs of often unanticipated deterioration. The result? An ongoing pattern of maintenance, patch and repair work to stay ahead of the harsh effects of increased truck traffic, heavier loads, and annual freeze-thaw cycles, overburdening taxpayers with the all-too-frequent need for redesign and rebuilding. As rehabilitation costs continue to exceed allocated budgets, it becomes clear that we are simply forcing 21st century transportation demands on 20th century road technology. In August of 1994, the world's largest and only live pavement outdoor testing laboratory became a reality. MnROAD, constructed by the Minnesota Department of Transportation, is a technologically unrivaled road research facility created to address and find answers to these problems. The rationale behind MnROAD? Current pavement standards, derived from tests performed in the late 50s and early 60s, are literally crumbling under the weight of increased traffic patterns, heavier commercial truckloads, and environmental damage. MnROAD, the Minnesota Road Research Project, utilizes state-of-the-art technology and 6 miles of test roads, providing unprecedented feedback and analysis to investigate factors affecting pavement response and performance. MnROAD's Pavement Research Center consists of 2 working laboratories. One, a mainline roadway carrying live interstate traffic. And second, a closed test loop, which is a controlled traffic low-volume road for city and county road research. Together, these segments contain a total of 40 500-foot test cells, representing a variety of types and depths of pavement surfaces, bases, subgrades, drainage, and compaction. The over 4,500 electronic sensors embedded in the test cells on both roadways set MnROAD apart as a unique world-class research facility. 17 types of sensors are embedded in both bituminous and concrete pavement surfaces, as well as gravel base and subgrade soil layers.
What we have here is a cluster of load response instrumentation as indicated by these paint marks. Those show the locations of strain, pressure, and deflection measuring instruments. Right now during spring thaw, we're doing a lot of data collection on these sensors because this is a critical time of the year.
Test cell construction includes a variety of current road building technologies. Researchers carefully measure pavement response and performance in each of the test cells. The test segments on both roads are engineered for 3, 5, and 10-year design lives, enabling researchers to study the effects and reasons for pavement failure long before the usual 20 to 30-year lifespan. Environmental sensors are located evenly throughout the site to measure variations in soil states, temperature gradients, and water table elevation variables. The MnROAD site was chosen partially for its higher water table, enabling researchers to study freeze-thaw effects more closely. Every day, MnROAD's extensive on-site data collection system electronically sends over 30 megabytes of information to researchers at the MnDOT Materials Research Laboratory in Maplewood, Minnesota, and at the University of Minnesota. In the near future, this data will also be accessible via Internet, offering the potential for data sharing with researchers throughout the world. With thousands of sensors peppered throughout the site, a weigh-in-motion scale, and an automated weather station in place, Min-ROAD measures loads as applied to test sections, plus environmental conditions such as temperature, precipitation, and solar radiation. In addition, Min-ROAD's extraordinary testing capabilities and unequaled on-site operations and research staff are available for cooperative projects and joint testing for states, countries, academic institutions, and the private sector. Research partnerships have already been developed with the Federal Highway Administration, the University of Minnesota, and other organizations, both public and private.
To my knowledge, Min-ROAD is the most aggressive pavement research facility in the world. And this partnering opportunity has given the Finnish National Road Administration a possibility to conduct cooperative pavement research and testing at the Min-ROAD site for all the Finnish roads. And over the next 20 years and beyond, the information collected will help us design stronger, longer-lasting and safer roadways in our country.
In fact, Min-ROAD takes data gathering to new levels of accuracy, measuring the critical effects of live traffic and actual environmental conditions on pavement deterioration as it happens.
We think it's going to be very, very significant in terms of new pavement designs, and of course the winners in this is going to be the public. Hopefully we'll be able to come up with higher quality pavements, reduce the amount of downtime of those pavements, so in effect reduce the inconvenience to the public, and also be able to accommodate industry in terms of what we know is going to be heavier loads, bigger loads in the future, because we don't see a diminishing of the need for motor carrier transport. So it's very exciting times for us engineer types.
By its very design, Min-ROAD is tailor-made for pooled funding and other partnering opportunities to facilitate cooperative projects. Partnering opportunities like the one currently underway with Finland play an important role in Min-ROAD's overall strategy to test and develop emerging pavement technologies. Min-ROAD partnerships allow transportation departments, private companies, pavement researchers and designers, and academic institutions to recreate their specific conditions in a live or controlled laboratory setting. This is an unprecedented opportunity to play a proactive role in extending pavement life, reducing maintenance costs, and developing safer, more reliable road systems. From utilizing existing test cells to building new ones to match your conditions, Min-ROAD offers a worldwide exchange of ideas, data, and analysis.
Well, I think the opportunity for potential partners at Min-ROAD is very broad. You have to think about how Min-ROAD is constructed and what opportunities it affords. The immense instrumentation, the fact that there are 40 highway segments, that all of this is linked by computer so that we can get real-time information out of the performance of those pieces of highway, that each of those sections is built differently. If we think about the fact of materials, instrumentation, construction processes, different design in highway, all of those are going to teach not only us here at Minnesota DOT, but other people in the universities and other transportation centers and DOTs throughout the world.
Extending pavement life, reducing maintenance costs, and developing more reliable road systems is what Min-ROAD is all about. The Minnesota Department of Transportation has dedicated this remarkable testing facility to finding facts that will lead the industry in developing cost-effective methods to build longer-lasting, safer roads and highways. Together, we can build a better foundation for the future.